Remember this little section here that we skipped? This whole section here in the middle on our periodic table. These are what we call the transition elements, or the transition metals. And we call them that because they can take on more than one charge. Now, some periodic tables will show you this. If you look at copper, for example, there's a +1 and there's a +2 in that little box. I don't know if you can see that very well. But what that means is copper can have a +1 charge, or it can have a +2 charge, depending on the conditions under which it bonds, I suppose. So let's just say that we have, let's say we have a compound with copper and chlorine. In this case, we know that chlorine has a -1 charge, and we know that copper in this case, and if this is balanced, this must have a +1 charge. We can also write a copper chloride with 2 chlorines. So if chlorine has a -1 charge, it can have 1 chlorine bonded with copper if copper has a +1 charge. Or if we have 2 chlorines, that must mean that we have 2 total negative charges. And so copper then must have a +2 charge in this particular compound. Now it is really important to be able to distinguish between these because these two compounds are very different. If we were to look at copper chloride with just 1 chlorine and copper chloride with 2 chlorines, they look very different. They have different properties. They're 2 different chemicals, even though they're made up of the same things. So what we need to do is we need to be able to balance these, and we need to be able to write these in a way that distinguishes which particular form of copper that we're using. And there's a couple ways to do this. Okay, one is using Roman numerals. And this is the most common anymore, and so that's the one that we're going to focus on. If we look at this copper, we know that chlorine has a -1 charge, and we know that because chlorine is over here in this halogen column. Okay, it has a -1 charge. So chlorine has a -1. If there is only 1 copper combined with this 1 negative chlorine, that must mean that this copper has a +1 charge. So when we write this, we're going to write it very similarly. We have copper and we have chloride. To indicate that this copper has a +1 charge, we are going to put a Roman numeral 1 in parentheses. Now, if you don't remember your Roman numerals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's, yeah, those are more than what we would need. These are your Roman numerals in order from 1 to 10. Okay? So if we look at this one, all right, chlorine still has a -1. Chlorine's charge does not change, but we have 2 of them. So if we have 2 -1 charges, that must mean that if we have 1 copper, this 1 copper has to have a charge of +2 in order to balance this out. So since we have a -1 chlorine and there are 2 of them, we have 2 total negatives. So if we only have 1 copper, then that must mean the charge on that copper is +2. So we're going to write that copper to chloride. Now what if we have iron oxide or iron oxide? Okay, iron is another transition. Iron is found right here on our periodic table. Oxygen, remember, is over here, has a -2 charge. So in this case, we have a 2 negative on our oxygen. If this is true, our total negatives are 2, and we only have 1 iron. So that must mean that the charge on our iron is a +2. So if we have 1 of each, those have to balance. So we have iron to oxide. Now if we look at this one, the charge on oxygen is still -2, and we have 3 of them. So if we have 3 -2s, that must mean that we have 6 total negatives. So that must mean we need 6 total positives to balance that out. Well, in order to get 6 total positives out of 2 irons, each iron must have a charge of 3 positive. So the iron in this case has a 3 positive charge because there's 2 of them. And to balance out 6 negatives with 2 irons, we need 3 positives. We would have iron 3 oxide. Now here's one that's fun. Oh, let's see here. What would we have? Manganese is a really fun element because it can just do all kinds of things. Let's see if we do that. Okay. Manganese can have a lot of charges. Now I want to point this one out because Mn is not the same as Mg. Over here we had Mg, it was magnesium. Mn is manganese. It is not the same as magnesium. This is one that is very common to mix up, so be very careful when you're looking at that second one. So we're going to have manganese on all 3 of these. Let's go ahead and write that. All right, so what are we going to call these? We need to look and see what our charges are. Oxygen is still a 2 negative. So if we have 1 of each, we have a 2 negative. This must mean that manganese is a 2 positive. So we have manganese 2 oxide. This one I love. All right, so here we've got a 2 negative, but how many do we have? We have 7. We have 7 oxygens in this compound. So 7 oxygens, each one has a 2 negative charge. We have 14 total negatives in this particular compound. Now in order to balance that, we need 14 total positives. And we only have 2 manganeses to do that. So in order for manganese to balance out 14 positives with 2, we must have manganese 7 oxide. All right, now this one is really similar to our iron 3 oxide up here. We have 2 manganese, we have 3 oxygens. Oxygen is still -2, that does not change. So if we have 6 total negatives, because we have 3 oxygens, each one has 2 negative charges, so we have 6 total negatives. In order to balance that out with 6 positives, we have 2 manganeses, so we must have manganese 3 oxide. Okay, so our transition elements. We need to make sure that we are looking at what it's bonding with. The negatives aren't going to change. Those are not transitions. Chlorine will always be a -1. Oxygen will always be a -2. The negative elements do not change their charges. Now, what if we want to write the name? Or not the name, what if we want to write the formula? Let's just say, that we have, let's go nickel. Nickel 2 chloride. Okay. If we see this name, this is the hint. This right here tells you how to write that formula. Because we know that nickel is right here. Nickel's here in the middle. It's a transition. So nickel, what we know is that our Roman numeral is 2. This tells us the charge. Okay. The Roman numeral tells you the charge on the nickel. So nickel has a 2 positive charge. Now if we look at chlorine again, chlorine is a halogen, so it has a -1 charge. So to write that formula, we have to balance we need 2 chlorines to balance our positives and our negatives. So we would need 1 nickel and 2 chlorines. So the key is, if you see this written down, you know it's a transition. And you already know the charge. You don't have to look it up. All you have to look up is the symbol. This Roman numeral in the name tells you the charge on your metal. Okay, the charge on your metal. So if we have lead, let's go 4. Bromide. Make this up as we go along. Okay, so we have lead 4. Lead is Pb. That means it has a 4 positive charge. Bromine is over here. It's a halogen, so it has a -1. And in order to balance that, we would need 4 of them. So we would have Pb, Br,